I'm Effie Parks. Welcome to Once Upon a Gene, the podcast. This is a place I created for us to connect and share the stories of our not-so-typical lives. Raising kids who are born with rare genetic syndromes and other types of disabilities can feel pretty isolating. What I know for sure is that when we can hear the triumphs and challenges from others who get it, we can find a lot more laughter, a lot more hope, and feel a lot less alone. I believe there are some magical healing powers that can happen for all of us through sharing our stories, and I'll take all the help I can get.
Once Upon a Gene is proud to be part of Bloodstream Media. Living in a family affected by rare and chronic illness can be isolating, and sometimes the best medicine is connecting to the voices of people who share your experience. This is why Bloodstream Media produces podcasts, blogs, and other forms of content for patients, families, and clinicians impacted by rare and chronic diseases. Visit bloodstreammedia.com to learn more.
Hey friends, welcome to Once Upon a Gene. I'm your host, Effie Parks. Some super exciting news. Once Upon a Gene just won first place in the category of cause awareness for the International Positive Change Podcast Awards from Speak Up Talk Radio. Yay! Oh my gosh, thank you all so much for being such a partner and supporter and friend to me and the show. And it's my honor to meet all of you and talk with all of you and share your stories and be a home base for families like ours. So yay us. Let's see, other things in the news. You know our friends Daniel DeFabio and Bo Bigelow over there at the Disorder Channel. They've started a new show and it's going to debut on December 23rd, 2022. It's called Pain Points and it's just in time for Festivus and the airing of grievances. You'll see a lot of friendly faces and friends of the show, like Billy Short, Patrick James Lynch, Kay Weaver, Jessica Pate, Bo Bigelow, etc., etc. There's going to be a bunch of amazing guests. Each talks for about 2 to 4 minutes. It's funny, it's cathartic, it's informative. We take rare disease very seriously, and everything else, not so much. So it's available exclusively for free on the Disorder Channel, which you can download on a Roku or an Amazon Fire. Okay, now for my guest. Holy bananas. You know who I'm talking to, right? You looked at the episode? Okay, well, she's basically the shepherd of almost a huge chunk of our neurodevelopmental diseases. And she's just one of the smartest people out there, and she cares about our kids deeply. And she has a profound purpose to make this world a better place for families like ours. I can't wait for you to talk to her. Make sure that you share this episode with every single person that you know, especially if you have a patient advocacy group. She goes over a bunch of things that are super important, critical to pushing things forward and getting things organized for our rare diseases. She's telling us about some new exciting projects she's working on, and I'm just so thrilled to have had this conversation with her. I know you're going to learn a lot and be reminded of some super important things. So again, please make sure to share this episode. There's a lot of active takeaways that you got to bring to your groups. So without further ado, please enjoy my conversation with Dr. Wendy Chung. Hi, Wendy. Welcome to the show.
Thank you for having me.
Yeah, I can't believe I have Wendy Chung here for a recording in your precious schedule. I'm pretty sure most of our friends listening right now who are listening right away know who you are. But for the families who find this episode later, who are just beginning their rare disease journey, please tell them who you are.
My name's Wendy Chung. I'm a what they call medical geneticist based at Columbia University. So I'm a doctor that takes care of people with rare genetic conditions. And I also do a fair amount of research to try and provide the answers and the treatments for things we don't have answers and treatment for today. So we do what I think of as the care until the cure, but ultimately trying to come up with cures.
Thank you. How about Simon's Searchlight? Can we get a little rundown on Simon's Searchlight?
So I'm what they call the principal investigator of Simon's Searchlight. It's something we've been doing for about the last 11 years, I think, if I've got my numbers right. It is infrastructure that supports individuals with about 170 different rare genetic conditions. All of them are neurodevelopmental conditions. Within this, they can be anywhere in the world. And with doing this, we're trying to use science to be able to come up with answers to give us hope for the future. And with this, we do research that people can do online. They can do it remotely. They can do it in many different languages. And that information gets distributed, de-identified, so no one knows who it is, but to researchers around the world, those that are in academic laboratories, so universities, hospitals, but also people that are in companies that are working towards treatments. We don't make any money. We don't pay any, or we don't charge anyone anything to access the de-identified data, but we try and de-risk it, or we try and make it easier for scientists to do good science, to put together individuals and families essentially with scientists and with people who are trying to come up with better tomorrows.
Thank you. I want to talk a little bit about getting patient advocacy groups more involved. What can be done to get more of the parents involved in the research part? And I mean this from the parents actually taking part and not necessarily the parents organizing it.
So I think one of the things is that life gets in the way, right? Life is complicated. Life is busy. Life throws us curveballs all the time. And so at least for the research that I've done, I've been trying to think about how to make it more accessible and to come where people are rather than make it harder for them to do. So I won't say that, I've completely solved this problem, nor has anyone else completely done this, but we're trying to make it more frictionless. In other words, make it easier for people to do. If you can do things, for instance, online, then you can do it on your schedule rather than having to make an appointment. You can do it online. You don't have to come to a major medical center or city to do it. It just gives you a lot more freedom in terms of doing that. We're trying to make it so that people can do this and they don't have to do everything in one sitting. They can do little bite-sized things at a time. But one thing we do know is important is to do this over time. That is that what a child with one of these conditions looks like at 12 months of age might be very different at 12 years of age. And so it's important for us all to be able to look at the same person over time and see how things evolve. And one of the things I've personally been noticing is that there's what we call a cohort effect, or there are individuals who are born in this decade that are looking different overall from individuals born a decade ago or 2 decades or 3 decades ago. And so one of the things within this is to try and understand what's different over time. I hope that it's earlier recognition of issues and treatments and support for those. And then we try and get down to specificity of, but what specifically did some parents do? And so one of the things is that this is also about parents helping other parents or families helping other families, in the sense that something that you may have observed, something that you may not have even appreciated, but that you're reporting in the data may help someone else. And reciprocally, someone else may help you to inform, the things that are working or the things that are really causing problems. So as we do this, we're helping each other out, pulling each other up as we're going along this journey.
Yeah. How can we help the families understand that doing so gets them a seat at the table? And what does getting a seat at the table really mean?
Yeah, that's a really important point. So for some of the conditions, people are unique. That is, genetically, even though you might be in the same gene group and everyone in your group might have the same gene, your child might have a different genetic variant than someone else in the next state or the next country. And one of the things that I pay a lot of attention to is what different researchers are doing in terms of trying to develop treatment. And as they're doing it, all genetic variants are not the same. They don't necessarily act in the same way. They might have different mechanisms in terms of how they're treated. I'll use a lot of big words, but whether someone uses an oligonucleotide, whether someone uses a gene therapy, a gene editing strategy, there are differences based on many different variables. And as people are trying to think about doing that, if you don't participate, if you're not represented, you may miss the boat. And I don't mean to, well, I do actually mean to be very transparent about that. That is that your voice, if it's not heard, there's no one who can advocate for your child. And there's no one who can replace your child. There's no one who can substitute or swap in for them. And believe it or not, this represents, even if someone else might have the same genetic variant, if they don't live in the same place in the world that you do, there may be researchers who want to do research specifically in Australia. And if you don't live in Australia, then you know what? They may decide to work on something something else. So it's really important, and really you're the only person you or your child is the only person who can represent that individual. No one else can really take your place. The other portion of this is that within the rare disease conditions, we really have to stick together, and numbers matter. And so everyone really needs to be counted, because if a group decides, well, I'd be willing to work on any condition if there are at least 50 people in the world that have the condition, then you want every one of those 50 people in your community to be counted and to be heard. In some cases, it might be more than that. And just, many people know me will say that 100 is a magic number. It's not absolutely magic, but 100 people in the world with the condition, people start thinking differently than if there are 5 people in the world. 500 is even better than 100, 1,000 is even better than 500. And I'm sure for many of our rare conditions, what we represent in terms of numbers who've been counted are a small fraction, in some cases less than 1% of the people who are out there with the conditions. So part of it is to make sure you're counted. The other part is to make sure we count everyone and figure out where all those other people are. And so that's something collectively I and others are working to try and make sure that we do.
Yeah. How are you doing that? How do we find as many patients as possible and build the community through genetic testing and organizing all the data like Simon's? Like, how do we find them? How do we get them those tests? Is this part of like the accessibility to testing that you kind of mentioned earlier?
Like you said, with many of these conditions, as much as I would like to be able to just by looking at someone and recognizing the diagnosis, I can do that sometimes. But truth be told is we need the genetics. And so what's scalable is being able to do, as you said, the genetic testing or genetic sequencing to make the diagnoses. Many of us have for many years advocated in terms of access to genetic testing, making sure that we don't leave anyone behind. We've done lots of things in terms of working with insurance companies, state Medicaid, all sorts of things, even the federal government and 21st Century Cures, to make sure there's legislation and policies in place to help. And we're getting there. We're not perfect by any means, but we're getting there. We do a better job for children than we do for adults. And one of the big gaps in our knowledge, I will say right now, is adults. By adults, I mean people that are in their 20s, 30s, 40s, 50s with these conditions, to know what the challenges are over the life course and how those differ. And one somewhat radical idea, but I will say it's one that I've thought a lot about and families have helped me think a lot about, is really being equitable. And so when it comes to genetic testing, for a variety of reasons, we're not equitably making the diagnosis. And so we've come up with a different solution to that, which is newborn screening. And so in the United States, as well as many parts of the world, there are opportunities, in fact, not just opportunities, but there's a public health infrastructure in place where we do a heel prick and get literally a couple drops of blood from a baby's heel to be able to screen for treatable conditions. And so we're running a study called Guardian right now in New York City. It is a study, but where we give families, parents the opportunities to do expansions of newborn screening to test for other conditions. And included within this, although it's at this point about 250 conditions, about 100 of those 250 conditions are conditions that parents have the option of opting in to get, which are neurodevelopmental conditions, many of which are associated with epilepsy. And the reason being that early recognition of seizures and treatment thereof, ultimately, I'm convinced will help improve the outcomes. And so it's a pilot study in terms of seeing how that works, how well it works, and assuming that it does work well, we'll continue expanding it. And within this, all of these conditions that I'm describing are things that we're absolutely certain are going to cause issues. So they're not sort of maybe kind of, they're things that we're very certain of, and that we've also got something that's medically actionable, something that we can do, news we can use. And so it's a pilot that other people have heard about and are starting to replicate in other places around the world. And I think this could be transformational in terms of, as you said, getting people to a diagnosis for the next generation, and potentially maximizing our ability to, start kids out on the right foot in terms of being able to improve those outcomes.
Yes, Wendy. I hardly think this is radical. I also think it was the best news of 2022, the Guardian study. Is it at this point kind of an invite only, or can any neurodevelopmental disorder, especially if they present with seizures, can they apply to get on the study?
That's a great question. So right now we are applying consistent, rigorous way of evaluating nominations. So anyone is free to nominate a condition, and it's not only neurodevelopmental disorders. It can be conditions that have to do with visual impairment, metabolic conditions, immunodeficiencies, anything really that's a serious medical genetic condition that has a treatment available. And the criteria that families asked us to use are that it's something that affects children young, so by age 5 is what they've asked us to define as young. And again, that we're certain of this and that there's a treatment. And so we take nominations from anyone. Anyone can make a nomination. If anyone wants to, they can email me at wkc15@columbia.edu. Then I'll send you the nomination form. But anyone can nominate anything. We have a group of doctors, geneticists that think carefully about these and apply consistent criteria. And we will continue to expand the testing over time, both as more conditions are treatable, as we have greater confidence in our ability to make these diagnoses. But the beautiful thing about how I've set this up is that it's very flexible, and we can continue to evolve this in real time. And my hope is that we'll have treatments that will warrant, I hope, over time, significant expansion.
Yeah. Oh my gosh, Wendy, thank you so much for that work. And you're right, transformational is exactly the way to define what's probably going to be the end goal here. I want to talk about natural history studies. There's a lot of confusion with families on why it's important and what it is exactly. Some people think their natural history study is simply what they're doing at Simon's and not anything extra. Some people are told they don't necessarily have to have one. What is kind of the general answer that you would give a patient advocacy group about natural history studies?
Great question. It's absolutely critical. And if your condition is newer and the natural history is not known, I can tell you it's 100% critical for the group and even for you individually, for your child. So what is natural history? It is how this condition evolves and how it changes over the life course without treatment or a cure that, might be really, like I said, cure, cure with a capital C. We do this because we need to know what things are like without a treatment. And then what we're going to do is compare what happens with a treatment. Now, one of the things that happens with children is children develop, right? And for those of you who have children either with one of these conditions or children without, things change over time, right? They hopefully, in a positive way, children gain skills over time. For some of your conditions, unfortunately, children may also lose skills, either permanently or at least for some period of time. But we need to know what that is. And so I think of it as a line, and we know what, I know this is a podcast, so you can't see my hands, but it's as if for normal children, quote unquote normal children, there's a line. And for children who might have neurodevelopmental conditions, they still have a line, but the slope is different. They progress more slowly. For some of them, they may even flatten out and be horizontal. If I want to be able to design a study where I test a new treatment or an intervention, the standard way of doing this scientifically would be to randomize people. That is that, some people get sugar pills, so to speak, or a placebo. Some people get the treatment. And I don't know who's who, and parents and patients don't know who's who. We're blinded, and that keeps us honest in terms of doing this. And so we administer these, and at the end of the day, we see how people did on the treatment. And then someone unblinds, maybe not me as the investigator, I'm blinded to this, but some other statistician unblinds this and looks at the data and says, is there any difference between the placebo or the sugar pills and the treatment? And that's sort of the way many clinical trials are done. When it comes to rare diseases, our numbers are so small that we don't want to sort of waste anyone. That's one thing. And the other is that I don't want to leave anyone out. And so if there's something that would potentially benefit someone, I don't want them to miss out and get the placebo. And so one way that we can do this is everyone is their own control. Everyone, we're comparing pre and post treatment. And if I have that natural history data to see how you've been doing over the last 3 years, for instance, and now January 1, 2023, I start trying the treatment on you, I can see what that slope has been over time. And now all of a sudden, if that slope increases, if suddenly your child is developing much faster, if they're gaining new skills at a much faster rate, then I can be able to say, it looks like maybe this isn't coincidence. If it's not just your child, but your child and 10 other children. But by having that run-in information, so before we start treatment, being able to see what their normal baseline was like, what their change was over time, each person can serve as their own control, and I don't leave anyone behind, and I come to answers faster by being able to use smaller numbers. So all of those reasons make it really important individually as well as for a group to have that natural history data. The other thing is that I don't always know what needle I'm going to be able to change. And so in treatments and clinical trials or in rigorous tests of being able to see if a new treatment's working, the FDA in the United States or other regulatory agencies in other countries say you have to pick a primary outcome. You have to have one thing that you're saying you can move the needle on. And we have to be able to see some of that natural history data to have a sense. Is it going to be seizures? Is it going to be falls? falls? Is it going to be vision? Is it going to be gastrointestinal issues? Is it going to be growth? Is it, there are a million things we could think about, but we're really literally betting the farm on one thing as we're doing this. And so we have to think very carefully about what can we measure, what can, in this group of individuals, what are they able to do? Where is their, we would call it dynamic range, but where is their variability that we might be able to move that needle and see improvements? Which things can the kiddos cooperate with? What are they capable of doing? And, so we can make sure we get reliable data. All sorts of things we're testing during that kind of testing period. And that's what the natural history also gives us the ability to do, is practice things, see how they're going to work before we get to the point where it's really mission critical in that clinical trial. So we're doing all of our homework, all of that practicing, all of that feasibility part of it. We're doing it up front so that we'll be ready for the day when it's time to run that race in the clinical trial.
All right. So starting your natural history study before you're doing your clinical trial, so you can learn more about the disease beforehand to help define your endpoints, which then could replace the placebo arm for rare diseases, right? Or is it still like that? I know there's talk about FDA changing that back to kind of how it used to be, but...
Yeah, we'll see over time. I think each time the FDA considers each application separately, despite what you may have heard, I do think they're reasonable people. And I think in the rare disease space specifically, they really are trying to help us in terms of getting treatments coming forward. And with this, like I said, we want to be able to, and I'll also put out there, when we start these new treatments, we don't know they're going to work, and they could even do something, that's harmful. We don't know as we start these. So we're trying to do these objectively. We're trying to gather the evidence, in a rigorous way to do it. But especially when it looks like there might be something there, when we have that kind of hint and we have maybe really good preclinical data in mice or other species that make us think there might be something there, we don't want to leave anyone behind. And so it's with all of that, to help us prepare for good, strong studies and to make sure that people can get access as soon as possible. We want to make sure that we've protected everyone in those ways.
Yes. Where can families find research to participate in?
Yeah, there are several different things. There's a website called clinicaltrials.org, one word, clinicaltrials.org. That's the easiest place, and you can usually type in your condition name, your gene name. You can try it a couple different ways, but that will give you generally what's available. It is skewed towards clinical trials with interventions. It does have sometimes researchers who are looking for biomarkers or natural history studies, but it's one in the United States clearinghouse where you can get a lot of information. So that's one easy place to look. When it comes to neurogenetic conditions, so the types of conditions that we've been talking about, of course, you would hear me say Simon's Searchlight. And so if you go to that website, it's Simon's, SIMONS, Searchlight, all one word, .org. And if you go there, there's a tab in the middle of the page. You can see genes we study and it's organized mostly by gene name alphabetically. You can see if your gene is there, or we have some copy number variants as well. And if you click on that, you can start joining that study. We do, for some of the Simon's Searchlight conditions, where family groups have family meetings, so where people are getting together in person. We also realize there's some utility to collecting in-person information we couldn't collect online. So as an example, last summer we had some family meetings where we wanted to be able to collect electroencephalograms or EEGs or electrical data from the brain. We don't have a way right now to be able to just reach through a computer screen and collect those EEG data, so we actually had people there who are specialists who brought their very fancy equipment and were collecting EEG data at family meetings. We had other things with other people assessing language or movement or how people think or how they speak. So all sorts of things that were easier to do and more reliable to do in person. And I won't say that everyone has to do that all the time, but those can be helpful in addition to what we do with the online surveys or standardized questionnaires.
Yes, we're trying to get that organized for our CT and MB1 conference this summer, so hopefully that'll happen. And also, I was just attending the SYNGAP Research Fund conference, and your team was there gathering all the blood draws for all the people who really just haven't had the time to get it done in their own busy lives of raising these kids. So that was very cool to see that.
Yep. So let me just say one more thing about the blood draw that you were alluding to is that at Simon's Searchlight, we've supported being able to make induced pluripotential stem cells. that are directly from individuals with these conditions. That allows us to, it kind of blows your mind, but from blood cells, be able to make cells that can effectively be like brain cells in a dish. And it allows researchers to develop treatments, test some things, do some experiments without having to expose actual people to things that might not work. So it becomes a very, very valuable resource and another way of making sure that you're counted, that you're represented.
Thank you for adding that. One more question about the blood draws. I know the ultimate blood that you want is the affected child typically, but a blood draw kit does come for the parents. But when they're spoken to at Simon's, they're like, yeah, it's not required, but you can do it. What would you say to parents about that? Is that actually more important? Would you like the entire family, if they're able to send their blood in?
So number one, in order of priority, we would like the individual with the condition for obvious reasons. Some researchers are actually asking for siblings who don't have the condition that are approximately the same age, a few years younger, a few years older, but that are sort of about the same. There may be some differences in what happens to cells over time. And then next after that would be the parents, if the parents don't have the condition. If the parents do have the condition, then the parents are just as important as the child with the condition. So within that order, that is the order in terms of what scientists have been using and asking for. And I can go into detail about why if people are interested. But absolutely the most important is the person with the condition, sort of, 10 to 1 importance.
Okay. What two things, perhaps, would you tell a family foundation to do if they have no money, but they want to get pharma ready?
So the most important thing to do is to aggregate your community. So these days, whether it's Facebook, whether it's another social media platform, but it's getting everyone together under one sign so you can easily be found, that people can connect with you, and importantly, stay together as one group. Don't splinter, don't make 5 groups, don't do, many different things by many different countries, stick together. You're too rare and to be fragmented and to not have the research community know where to find you. So that's the single most important thing that you can do. After that, leverage your power in terms of working together with other resources. And I will say Simon Searchlight is one of those resources, but there are other researchers who might be interested in your condition or your gene. Find them, let them work with you, let them leverage some of the resources they can get from federal agencies, whatever country they're in, whatever company they're at, but figure out how to leverage those resources as well and work with them. And some of them, if they're really good and know what they're doing, can actually be incredible advocates. The next thing I'd say is that within the communities, often what I see is that you can do an inventory of the skill sets of the parents and other family members in your community. And so if you do that, you'll figure out, wow, I've got someone who, for instance, is a really good communicator. I've got someone who's actually a scientist of some sort. Maybe they don't work on this condition, but they know something about science. I've got someone else who's great in terms of education, someone else who's great in terms of government affairs and advocacy. But do an inventory of what you've got and be able to then think as a group about how you'll divide and conquer. So, what are the important things to do? Who can advocate for you? Who has connections here, there, or everywhere? And be able to use those connections. And don't be, embarrassed to do it. You're doing it for your kids oftentimes. And many people, when they realize that, will open up their minds and their hearts in terms of doing that. As you're working with scientists, make it real. And, as you're doing this, don't be afraid to show them a picture, a video of the person you care about in terms of doing this. Help them understand what the struggle is for you, but make it real for them. They're real people. They care about the same things that, other moms and dads and grandmas and grandpas care about. And when they appreciate and understand what life is like for you, that it will naturally come through for most people that they want to be able to help you on that journey. So make it real for them, not just about the science.
Thank you. Well, I know that it's real for you, Wendy, in the obvious case, but Luke Rosen, I actually asked him permission if I could talk about this. And he said, yes, absolutely. He told me something that you told him once, and he said he's never forgotten it. He said that he had another kiddo that reached out to him and needed help and blah, blah, blah. And you said, you can always, always, always send me a family with a sick kid. And I just know how much you mean to him and how much you've helped with Suze. And everyone in our community is always asking about Suze, especially since she's on her first N of 1 ASO. and everyone's eager to learn about it and figure out how to scale it for all of the other children who are at least amenable to ASOs. And I was wondering if you'd talk a little bit about that.
First, I will preface this by saying that this story's not over, and I'm not sure how it's going to end. But what you described is that, and I'm saying this, as you said, with the Rosen's permission to be able to talk about this, is that we did, with a lot of other smart people, it was definitely a team to do this, work on trying to figure out an oligonucleotide, a small bit of nucleic acid, which can essentially get rid of what is poisoning Susanna's body. In this case, KIF1A oligonucleotide. Within this, it's not easy at all. It's not easy to be able to make it, to screen it, make sure it's not causing any problems. And so we've worked very closely with folks at Ed & Lorem, a private foundation, to be able, I give them credit for the science and the hard work to get the right oligonucleotide. And then they've passed that over to me to be able to think about how to administer it safely and to be able to measure whether or not it's having the intended effect and how we go through doing all of that. This is, unfortunately, the strategy is not a one and done strategy. It's something that we have to keep repeating, give the medication over and over, and it's not as simple as just a pill that you take. We have to get this to the brain, and we have to get this to the spinal cord and to the nerve cells. And so for any of the women out there who had an epidural when they had a baby, there's this little space around your spinal cord where we can stick a needle in, and we can also use that. We used it in epidurals, for instance, for you ladies that got medicine, numbing medicine. We can also, in this case, put ASOs in that same space, and that same, what we call cerebral spinal fluid, bathes the brain, the spinal cord, the nerves, and is able to get into the cells and, as I said, knock down or be able to get rid of the poison that's poisoning the cells. It's not easy to do. So being able to administer it at the right dose, not do any harm as we're doing it, we're still figuring out how to do this the right way. And as we're doing this, we're also figuring out how, in what dimensions we might be having an effect and how much of an effect we're having. It's difficult because I'll be very honest, there have been children, not that are my patients, but there have been children that have been treated with this type of strategy using an ASO that have had lethal complications. So it's no joke. And I give the Rosens a huge amount of credit for being brave enough to be the first in our KIF1A community to try this, because we didn't know how it was going to go, and I still don't know the end in terms of what the story will be. But I am cautiously optimistic. I'll say that I think we've got hints that we may be on the right track. I don't know how many iterative improvements we're going to have to make until we get, confidently to know that we're there. But I am cautiously optimistic that at least for KIF1A, we're going on the right track. And that gives me enormous hope for the future. Also, obviously, for Susanna, and I hope for the rare disease community that, there are paths forward. I don't know that ASO is going to be our answer forever. I hope this is a bridge to something better, because there are certainly things that are imperfect about this strategy. I don't think it's going to work for everyone. I don't think it's going to work for every condition, but I am very excited that we used the word transformational earlier. I do think there are some transformational technologies that are coming forward. I don't think they're going to be here in the next year. I do think they may be here in the next 5 years, and for some conditions it may be a bit longer, but I do think there's reason to have hope for the future. And that's one of the things I want to make sure the families hear about. There definitely is reason to have hope for the future.
Thank you. And cautiously optimistic coming from you, Wendy. That's pretty good. I mean, I'm going to take that. No, we're so grateful to all of you and Lorem, Luke, Suze, their family, for being the guinea pigs, I guess, if you will, for this, because it's not just for Suze, it's for all of these families. It's for our entire community, and they're on our hearts so much. And I know they're on yours, because I know you're so invested and you've created so many meaningful partnerships with families like mine. And your empathy muscle, Wendy, seems endless. And you seem to have a profound purpose, and you're helping so many kids. And I thank you for it.
Well, I'm fortunate. It really is. It's really the joy that I have, the purpose that I have, and it's my honor to be able to work with so many amazing families like you and like the Rosens and like the literally tens of thousands of others of you out there.
Thank you. Is CTNMB one your favorite? Just asking for a friend.
Now, it's just, like when you're a parent, you can't say any child is your favorite.
Oh my God. Perfect answer. Thank you, Wendy. Such an honor to meet you. In general, I can't wait to see you in person someday. And I'm so thankful to you. I appreciate your time. And I can't wait to share all of your expertise with the families here on this episode. Is there anything that I should have asked you or that you want to leave with anyone listening?
No, I just want to say we're in this together, right? So in the rare disease community, we individually might be rare, but collectively we're quite common. We represent 10% of all people with a rare genetic condition. And the more that we can raise awareness of that, the better we can advocate for all of us collectively. And I really do think that I call it a step function, but I think there are going to be transformational technologies and approaches for, number one, getting to the diagnosis, and then number two, getting to the treatments. And it's going to take us collectively as a community, all of us, to do. But we're a lot of people. 10% of the world is a lot of people. And if we stick together and work together, we're going to get there that much faster. So I think it's going to be, the next decade is going to be so much different than the last decade was. And I'm just, like I said, glad to be able to go on this journey with other folks. And anything I can do, I'm always glad to. As Luke said, if there's anyone that needs me, I gave you my email before, use it.
Amen. Yes. And you just went over so many shots on goal to make all of that true and real. So thank you, Wendy. I hope you've been enjoying this podcast. If you like what you hear, please share this show with your people. And please make sure to rate and review it on iTunes or wherever you get your podcasts. You can also head over to Instagram, Facebook, and Twitter to connect with me and stay updated on the show. If you're interested in sharing your story, or if you have anything you would like to contribute, please submit it to my website at effieparks.com. Thank you so much for listening to the show and for supporting me along the way. I appreciate y'all so much. I don't know what kind of day you're having, but if you need a little pick-me-up, Ford's got you.